There's one statistic that everybody seems to know about prehistoric humans. Say the words Stone Age to almost anyone, and within seconds they'll mention it. Life expectancy was around 30. It shows up in textbooks, trivia nights, half-remembered documentaries. And here's the strange part. The number itself isn't wrong. It's just telling you almost nothing true about what it feels like to imagine. Because the image that number puts in your head, a 30-year-old hunter-gatherer, gray-haired and stooped, dying of old age while the tribe shrugs it off as normal, is basically fiction. The real story behind why that average sits so low is stranger, and honestly darker, than people just aged faster back then. So let's actually pull this number apart and see what's hiding underneath it. Two very different averages. The first thing to understand is that life expectancy can mean two completely different calculations, and popular science constantly blurs them together. Life expectancy at birth averages the age of death across every single person born into a group, including babies who die within their first day. That average is brutally sensitive to child mortality, because early deaths yank the number downward, even if most people who survive childhood go on to live decades longer. Try this thought experiment. 10 people are born. 5 die before age 5, a grim but historically accurate rate for a lot of ancient and even fairly recent populations. The other 5 live to 70. Add up all 10 ages at death, divide by 10, and you get a life expectancy at birth of roughly 36. But look at what that number hides. Half the group lived to 70. Nobody actually died at 36. That figure describes the lived reality of essentially nobody in the sample. That, in simplified form, is almost exactly what's happening inside the famous Stone Age numbers. The average gets crushed by catastrophic infant and child mortality, not by adults dropping dead in their 30s. It's worth sitting with that thought experiment for a second longer, because the confusion it exposes isn't a quirk of my made-up example. It's baked into how averages work with any skewed distribution. An average is only a useful summary when the underlying data clusters somewhere near it. When a population is actually made up of two very different groups, a large cluster of people dying in infancy and a separate cluster living into old age, the single average number doesn't describe either group. It floats in a kind of statistical no man's land, corresponding to nobody's actual life. And yet, that's the exact number that gets lifted out of academic papers, stripped of context, and turned into a one-line trivia fact repeated in documentaries and casual conversation for decades. The far more revealing number is life expectancy calculated from a later starting point, say age 15, which tells you how much longer someone could expect to live once they'd already cleared the most dangerous years. And when researchers run that calculation on hunter-gatherer populations, using both skeletal remains and direct observation of surviving traditional societies, the picture flips. People who made it to 15 had a genuine, well-documented shot at living into their 60s or 70s. That's not a minor footnote. It's the difference between everyone dies young and most adults live a long life once they survive childhood. So why was childhood so lethal? This is where the real, darker substance of the story lives. Infectious disease sits at the top of the list, and its pattern shifted in a way that complicates the assumption that things simply got worse the further back you go. Small, mobile hunter-gatherer bands were actually somewhat shielded from many of history's deadliest epidemics. Diseases like smallpox, measles, and bubonic plague are density-dependent. They need large, concentrated populations to keep spreading, because in a small, isolated band, the disease burns through its hosts and dies out on its own. Which means, counterintuitively, that farming and permanent settlements made infectious disease worse, not better. Dense villages, close contact, proximity to livestock acting as disease reservoirs, and contaminated water all created ideal conditions for epidemics that scattered hunter-gatherers had mostly avoided just by staying small and mobile. It's part of why some researchers frame agriculture as a trade of one set of risks for another, more stable food and higher birth rates, paid for with a far more dangerous disease environment. This is worth pausing on because it cuts against a deeply ingrained assumption most of us carry, that human history is basically a straight upward line, with every technological step forward also being a step toward better health and longer life. The archaeological record doesn't really support that clean narrative. Settled agricultural life solved the problem of unpredictable food supply, but it opened the door to an entirely new category of mass death that small, scattered bands had simply never had to face at scale. Childbirth, the second great killer. Childbirth was lethal for two people at once, mother and infant. Estimates put the risk of a woman dying directly from birth complications somewhere around 1–2% per delivery. That sounds manageable until you remember women in these populations often gave birth many times over their lives. Across 8 births, even at a conservative 1% risk each, the cumulative lifetime risk compounds to somewhere around 7–8%. That's roughly one woman in 14 or 15 dying as a direct result of pregnancy and delivery. The causes stayed grimly consistent: hemorrhage, post-birth infection, obstructed labor with no surgical fix available, and preeclampsia, which remains dangerous even with modern medicine and was essentially untreatable back then. Worth saying plainly, this risk fell overwhelmingly on women. Any honest look at ancient mortality has to reckon with the fact that survival was never distributed evenly between the sexes. A man and a woman born into the exact same community at the exact same time faced meaningfully different odds of ever reaching old age, and that gap runs through nearly the entire historical record, not just the prehistoric portion of it, the children. Child mortality operated on an even bigger scale, and the numbers are hard to internalize from where we sit now. Estimates across pre-modern populations suggest somewhere between 30 and 50% of children died before adulthood, with the single deadliest window being the first 1 to 2 years, birth complications, infections hitting an undeveloped immune system with no antibiotics, malnutrition during food shortages, and sheer physical fragility. This is the real engine behind the low life expectancy at birth figure. The children dying in these catastrophic numbers weren't living shortened adult lives. They weren't living adult lives at all. It's a genuinely uncomfortable distinction to sit with, but it matters because it reframes the entire statistic. The number isn't secretly describing weary, prematurely aged adults. It's describing an enormous, silent loss concentrated almost entirely at the very beginning of life, before anything resembling an adult lifespan had even started. What about violence? This part of the debate is genuinely unresolved. Some researchers, using skeletal trauma evidence and observation of contemporary tribal societies, argue interpersonal violence and intergroup warfare accounted for a striking share of adult male deaths. In some populations, estimates run as high as 10–20%. Others push back hard, pointing out that the sites generating those numbers, mass graves, battlefields, skeletons with dramatic trauma, get disproportionately excavated and studied precisely because they're dramatic, which could skew the whole sample. Well-qualified researchers on both sides are still publishing conflicting numbers using different criteria for what even counts as violence-related trauma. It's an open question, not a settled one. The silent killer: no antibiotics. Accidents round out the list: falls, animal attacks, drowning, exposure. A broken bone, that means a cast and a few weeks off work today, could, without modern care, spiral into infection, permanent disability, or death. And this is maybe the single most underrated factor in the entire story: the total absence of antibiotics. A small wound turning septic could kill within days, a process that's now almost entirely preventable with a cheap course of medication. Childbirth infections, surgical infections, pneumonia after an ordinary cold, all of these were genuine mortal threats for nearly the whole of human history, right up until antibiotics arrived in the mid-20th century. Even a well-performed procedure, a properly set bone, a clean tooth extraction, could still turn fatal days later once bacteria took hold, with nothing to stop them. The gap between ancient and modern mortality isn't really about ancient bodies being weaker. It's about which tools existed to fight threats that have basically always been around. Surgical care is a good example of just how invisible this factor really was. A broken bone properly set, an abscess correctly drained, an infected tooth cleanly pulled. None of that guaranteed survival on its own. The procedure could go perfectly, and the patient could still die days later once bacteria took hold in the wound, with absolutely nothing available to stop the spread. That's not a failure of ancient medical skill. It's the absence of a chemical tool that simply hadn't been discovered yet. And this isn't purely ancient history either. Life expectancy at birth in the US and Western Europe was still only in the low to mid-40s, as recently as 1900, driven by the same overwhelming childhood mortality. Not because adults were dying young en masse. If your great-grandparents lived through that era, their household was statistically shaped by this exact same dynamic. Not some distant abstraction, but something inside living family memory. What aging actually looked like. So what happened to the people who did survive childhood? Skeletal remains of individuals who reached old age in prehistoric populations show the same degenerative signs we see today: osteoarthritis, worn teeth, healed fractures, sometimes osteoporosis. Contemporary hunter-gatherer societies studied extensively by anthropologists, the Hadza of Tanzania, various Amazonian groups, routinely include elderly people well into their 70s and occasionally their 80s. And these elders aren't marginal figures. They hold real social weight: caregivers, knowledge keepers, sources of authority. Anthropologist Kristen Hawkes, working with the Hadza starting in the 1990s, helped develop the grandmother hypothesis, one of the more compelling explanations for why humans, almost uniquely among mammals, evolved to live well past their reproductive years. The idea is that post-reproductive women who survived into old age boosted their descendants' odds of survival through childcare, food sharing, and accumulated knowledge, a benefit strong enough to help drive the evolution of a long post-reproductive lifespan in human females. If everyone genuinely died at 30, there'd be no evolutionary pressure for that kind of longevity to develop at all. Evolution doesn't preserve traits that never get expressed. The mere existence of long-lived grandmothers is itself evidence that long adult lifespans were a real, recurring part of human life deep into prehistory. Not every anthropologist thinks grandmothering fully explains it alone. Some point to male provisioning as a supporting factor too. But the broader point holds either way. Whichever combination of forces actually drove it, the underlying logic is the same. Evolution simply doesn't invest in machinery for a life stage that never gets reached. A body doesn't evolve dedicated post-reproductive social roles, hormonal shifts like menopause, or the physical stamina to keep raising grandchildren for a phase of life that's purely theoretical. The fact that this machinery exists at all in our species is itself a kind of fossil record, proof that long adult lives were common enough, often enough, for natural selection to notice and respond to them. A measurement problem hiding in the bones. There's another wrinkle worth knowing, because it's about how researchers even estimate age from a skeleton in the first place. Age gets reconstructed from things like growth plate fusion, pelvic changes, and dental wear, and these markers get far less precise the older someone was. Telling a 45-year-old skeleton from a 65-year-old one is genuinely hard, and for decades, the standard practice was to lump everyone over roughly 50 into one vague old adult bucket. This bias was formally called out in a 1982 paper, Farewell to Paleodemography, by researchers Bouquet-Appel and Massett, who showed mathematically that this kind of age estimation error systematically compresses genuinely old individuals into younger-looking categories, distorting life expectancy calculations across the whole field. If a sample actually includes plenty of people who died in their 60s, 70s, or 80s, but the method can only confidently say 50 plus, any life expectancy figure built on that data will underestimate how common long adult lives really were. One case makes this especially concrete. The skeletal collection from Libin, an Ohio Native American site dating to roughly 800, 1100 CE, became a textbook example precisely because of how thoroughly it's been re-examined. The original analysis produced a low average lifespan, with few people appearing to live past their 40s or 50s. Later reanalysis of the same bones, using improved aging techniques, told a different story. A meaningful chunk of people originally dumped into the vague older adult bucket turned out to have lived considerably longer. And Libin isn't unique. Across many skeletal populations re-examined since the mid-20th century, the pattern repeats. Early analyses undercount the elderly, and newer methods, including ones that examine microscopic bone structure rather than relying on crude pelvic and dental markers, reveal an older population than originally believed almost every time. It's a rare case in any scientific field where the correction consistently runs in one direction, not scattered randomly higher and lower with each new study, but skewing older, again and again, as the tools improve. That consistency is itself telling. It suggests the earlier low numbers weren't just noisy estimates. They were a systematic underestimate baked into the method itself. The modal age of death, 70 to 72. Researchers Michael Gervin and Hillard Kaplan compiled comparative data across contemporary hunter-gatherer groups, the Hadza, the Aché of Paraguay, the Hiwi of Venezuela and Colombia, in a widely cited 2007 paper on hunter-gatherer longevity. Their findings show a strikingly consistent pattern. Brutal mortality risk concentrated in the first few years of life, a sharp drop through adolescence and prime adulthood, then a gradual rise starting around age 40 or 50, a curve that mirrors modern industrialized populations, just shifted to higher rates at every age because of missing modern medicine. One number from their work deserves way more attention than it gets. The modal age of adult death, the single most common age adults actually died at, not the mean dragged down by childhood deaths, clustered consistently between 70 and 72 years old. Think about how directly that contradicts the mental image most people carry. The single most statistically common outcome for a hunter-gatherer who made it past early childhood wasn't dying at 30 or 40, it was living into their 70s. Farming wasn't automatically an upgrade. One more complication worth flagging: the shift from foraging to farming wasn't a straightforward health improvement. Skeletal evidence from early agricultural populations shows reduced average height, more skeletal stress markers, higher dental disease, and in some populations, increased rather than decreased childhood mortality during the initial shift to settled life, sometimes called the Neolithic mortality crisis. It complicates any tidy story where human health just kept improving as civilization advanced, and it should make anyone pause before treating farming as an unambiguous upgrade simply because it eventually led to cities and writing. So why did ancient humans actually die young? Here's the honest answer. A huge share of them didn't, not in the way the famous number implies. What actually existed was a brutal, mostly invisible filter sitting right at the start of life. Overwhelming infant and child mortality from disease, birth complications, and malnutrition, compounded by real maternal mortality and, more debatably, meaningful violence in some groups. All of it concentrated into the earliest years and the reproductive prime. Anyone who got through that filter had a genuinely common shot at living into their 60s or 70s, developing the same arthritis and gradual decline elderly people experience now, and often going on to be respected elders and knowledge keepers in their communities. The number 30 captures something real and genuinely tragic, the almost unimaginable cost paid in childhood death and childbirth. It just doesn't capture what most people think it captures. Modern medicine's real achievement was never raising some hard ceiling on how long a human body could last. Living comfortably into your 70s was always well within our species' ordinary range. The actual achievement was raising the floor, shrinking the number of people who never got the chance to find out how long they might have lived at all. That's a more remarkable story than the myth it replaces. A species that spent most of its history not with a hard biological ceiling on life, but with an enormous, largely preventable filter standing in front of it, and then spent the last century dismantling that filter, piece by piece, until reaching old age stopped being the exception and quietly became the expectation.